LeetCode 49. Group anagrams isn't just a warm-up. It mirrors real-world challenges in search engines, bioinformatics, and user input cleanup. At massive scale, brute force breaks down fast. So how do we turn this clunky duck paddle into a high-speed glide? Let's dive into two sharp strategies and cut through the clutter. All right, ducklings, time to test the waters with a good old brute force approach. We'll compare every word to every other to group anagrams. Not elegant, but it lays the groundwork. First up, let's define a helper method to check if two words are anagrams by comparing their character counts instead of sorting them. As a quick optimization, we bail early if the words are different lengths. No point checking mismatched pairs. To track letters efficiently, we'll use an array to count each character, much faster than using a hashmap. We scan the first string and bump up the count for each letter, building our character profile. Then we scan the second string and subtract each letter's count. If anything dips below 0, it's not an anagram. If the counts all land back at 0, the two words match. They're anagrams. Back in the main logic, we'll use a Boolean array to keep track of which words we've already grouped, so we don't process them twice. We also prep a list of lists to store our final result. Each inner list holds one group of anagrams. Now we scan through the array of words. Each word acts as the anchor for a potential new group. If we've already grouped this word earlier, we skip it. No need to check it again. If it's a new one, we start a fresh group and drop the word in immediately, since it's always an anagram of itself. We mark it as grouped to avoid duplicate effort later on. Next, we look at all the words that come after this one and check if they're anagrams of our base word. If we find one that matches and hasn't been grouped yet, we toss it into the group and mark it as used. Once we've scanned the rest of the list, we lock in the group and add it to our result. After processing every word, we return the full list of anagram groups we've built. This brute force solution runs in big O of n squared times k, where n is the number of words and k is average word length. At 10,000 words, that's up to 100 million comparisons, slow and heavy. Space-wise, it's big O of n times k for the data we hold. Let's pick up the pace with a cleaner method. Instead of checking every pair, we'll group words by a shared signature, their sorted letter form. Let's see how that sharpens things. We'll build a hashmap where each key is a sorted letter signature, and each value is a list of words sharing that signature, true anagrams. Scan through the input list, grabbing one word at a time to process and group. We convert the word to a character array so we can sort the letters directly. That's the heart of the anagram check. By sorting the characters, we normalize the structure. All anagrams produce the same result after sorting. Turn that sorted array back into a string. That string becomes our key for grouping. Drop the original word into the map under that key. If it's the first of its kind, create a new list on the spot. Once we've processed every word, we return the values of the map, each one a group of anagrams. This version runs in big O of n times k log k, sorting each word, then doing fast hashmap inserts. For big data sets, that's a massive savings. Space is still big O of n times k sorrow. For storing the words and map entries. Clean, scalable, and built for interviews. We kicked off with brute force, solid for learning, but way too slow at scale. Then we leveled up with a hashmap keyed by sorted letters, slicing redundancy and boosting efficiency to big O of n times k log k. This isn't just faster, it echoes real-world practices like using normalized keys to deduplicate data. Sure, there's a slightly faster trick using letter counts as keys, shaving time down to big O of n times k, but it's harder to code under pressure. The sorted key approach hits the sweet spot. Easy to write, tough to beat. If you're prepping for interviews or building real systems, this pattern is gold. And if you're hungry for more, try applying it to streams, caching, and clustering. Keep your feathers sharp and keep flying forward.